NetSparker, the developers of desktop and cloud-based web application security scanners that enable you to automatically identify vulnerabilities in your web applications and web services. NetSparker scanners employ a unique and dead-accurate vulnerability scanning engine that automatically verifies vulnerabilities with their proof of concept. For more information, visit them on the web at netsparker.com or email at contact@netsparker.com. Signal Sciences secures the most important web applications, APIs, and microservices of the world's leading companies, protecting over 7,500 applications and 150 billion production requests per week. Signal Sciences Next-Gen WAF and RASP help companies increase security and maintain site reliability without sacrificing velocity, all at the lowest total cost of ownership. Signal Sciences' patented technology protects any application against any attack, with integrations into any DevOps toolchain. Signal Sciences. Demand more from your WAF. Learn more at signalsciences.com/PSW. Welcome back, everyone, to Paul Security Weekly. We're going to come at you with a technical segment very soon. But first, if you're interested in quality over quantity and having meaningful conversations instead of just a badge scan, you should join us April 1st through the 3rd at Disney's Contemporary Resort for InfoSec World 2019, where you can connect and network with like-minded individuals in search of actionable information. Use the registration code OS19-SECWEEK for 15% off the main conference or a World's Pass. Matt Toussain is here with us, no stranger to the Security Weekly show. Although I do have to apologize for Matt the last time he came on to talk about vulnerability management, and it happened to be Jack Daniel and myself who were here in studio. We had a very lively and engaging conversation about vulnerability management. But Matt actually came back after. It took him a while, I think, to recover from that. And now Matt is back to talk about a technical segment that I will let you describe.
Yeah, absolutely. I needed at least a year to cool down after calling Nessus, unfun to Jack Daniels and explaining why we were using Nexpose in the class.
Blasphemy. Blasphemy.
It didn't end well. it was
just blasphemous.
It was ugly. It was ugly.
But instead of reliving the past,
let's move on to the future. Yes.
All right. Well, what we're talking about today is remote access tools, or RATs. I've been doing a lot of work on these for the past year or so. At Black Hills for penetration tests, it's been a really big facet of the things that we've been doing. So at DerbyCon alone, Marcello Savati and myself, we both did a talk, and both those talks we were releasing new backdoors to get around a lot of the EDR systems that we're experiencing in penetration tests today. And we've, at Black Hills, I think we're up to 5 unique backdoors that we've created just in this past year, so 2018 alone. And a lot of this has to do with kind of a problem we're experiencing in InfoSec in general, and that's that EDR solutions and such, host-based protection systems, are really focused on the tools, the open source tools, mind you, that we're using in penetration testing, which is painful for us because we still need to be able to do our jobs. And the risk that we need to actualize and demonstrate to our clients is it's got to be the same as whatever the adversary, the real threat that they're facing on a day-to-day basis, which if they're using custom tools, we need to be able to be at least as successful as those custom tools. Otherwise, what are we getting paid for? So we've been doing a lot of that here at Black Hills. And I talked to Dave Kennedy at TrustedSec about the same kind of thing. And I think it's just a whole problem that we're experiencing as a community as a whole, is that if we're doing a test for someone who's really secured their environment quite well, and that's outstanding, there's a perfectly reasonable chance that we might get embarrassed on the test, which, if they're really secure, then absolutely well done. But on the other hand, if we're getting embarrassed, the attackers are getting in wholesale, then that's a real problem. We don't want to have that kind of false sense of security being provided to a customer who then gets exposed simply because we were unsuccessful, because we're ineffective as pen testers. So there are a couple ways you can get around this. And so the first one is you can just do better bypasses. You can do more of them. Joff has done a ton of work on this over the past year, bypasses for Cylance, getting us as Black Hills on the edge of being sued by insert vendor here. But when you're doing these bypasses and when you release them open source, it's very easy for a vendor to go in and start patching those holes. So the question is, do you not support the open source community? And that's something that we're really passionate about at Black Hills, about continuing to release tools and techniques open source, being part of that community, because without open source, without the community as a whole, our post-exploitation capability would be really small. We wouldn't be able to compete with nation-state level intrusion sets. So it's something we're certainly passionate about. But then at the same time, we have this spectrum that we've got to be on, because we need to make sure that whatever we do, whatever we release, that at the very least, we're still serving our customers properly and giving them the best service that they possibly can get. So then you get that question. The alternative to that, and this is the spectrum or the side that I would like to be on, but it is the harder one, and that's just to do more, do it faster. With PowerShell, we saw quite a bit of this over the past 5 years, PowerShell Mafia and such. A lot of folks working on some really, really cool tools in PowerShell. But now with some of the handles that Microsoft's built into, say, Windows Defender and such, it's become a lot more difficult to use PowerShell in a lot of more secure environments, which takes away like 5 years of development and toolkit provisioning and creation that we've done as a community. And I'm not saying it's gone, or that it's going to be completely gone, or that PowerShell's dead. I think we're having some situations where that is true, but by no means do I think PowerShell's not really usable anymore. But what I do think is that we're seeing a lot of change happen. We're specifically seeing that change in the top 5% of organizations out there right now. So in the bottom, say 95%, it's 95% of your penetration tests, not really an issue at all. Standard toolkit tends to work pretty well. And you can do some pretty basic bypasses. We were doing a test just a couple months ago where we wanted to have Meterpreter and Cobalt Strike in the environment. It was very simple to install Python and just invoke things through Python directly, because EDR systems just don't put a lot of work into building insight into things that you don't typically see on a Windows environment or on Windows systems. So there's definitely still a big portion of, say, organizations who've got a lot of work to do, and they're not necessarily in the ballpark when it comes to this kind of problem or overcoming these issues. But so my thought is
now, Matt, my question is, so if you have a Python kind of payload that you're delivering and it's bypassing a lot of the EDR products and endpoint protection, that's all well and good. But as an attacker, you need to go on to the next step and maybe start dipping into the domain or doing some other investigative work from that point, and that could then trigger alarms, even or maybe not, depending on what the organization's looking for after that
absolutely.
point, right?
And that's in fact what we're trying to push our customers to do, is to look at post-exploitation as the opportunity to perhaps even weaponize their environment, if you will, to give more insight there as opportunities to detect and then block. Because I think blue teams have this whole concept, and it's brought about, I think, perhaps by us on the red side, our ego, if you will. And it's that we're going to win. And so the blue teams always think, hey, red's eventually going to get in, and then I've lost. Red only has to win one time, but I have to win every time. But when it comes down to it, exactly like you said, when you get in, well, that's when the red team, the pen test, the insert here, that's when it really starts. That's when you have to do everything else at that point. And I think that's also where we need to really focus on defensive controls and preventing things from happening, and specifically detecting it when certain actions are taken on the environment. And I think when you look at those things, those are more at the tactical level than they are at the, say, technique or procedure where you're trying to block based on signature style detection. I think when you look at that level, when you look at those kind of activities, you're going to see us as red teamers and pen testers just as quickly and properly as you would see intrusion sets or criminal organizations, because they're going to be doing the same kind of processes. They might not have the same tool, but if you're looking for that post-exploitation activity as a whole, then you have a lot better opportunity to really detect and block and secure your environment, to go through eradication if you need to, handle the incident, whatever the next steps might be, but at least you can then do something about it. I think we see a lot of EDR products these days that aren't focused on that problem. They're focused on that first, prevent them from getting in, which is all well and good. I'm not saying don't lock down your environment by any means, or don't prevent open source backdoors from working on your environment. Because intrusion sets, they'll use that too. If that's the easiest way to go, if it's the free, cheapest way to go. But at the same time, if your pen testers can't be successful in execution, that's a step that's eventually going to happen. That's kind of the given. But like, as you said, it's that post-exploitation phase that you really need to lock in on and focus on as a defender, as an organization that's trying to get better, as a blue team that's trying to succeed. So that's what we're trying to push our customers, our clients to actually go out and do, because I think you're absolutely right. It's that post-exploitation phase that really matters. which means for us as pen testers, we need to have a way to get to that phase as quickly as we possibly can.
Yeah, I was going to say, because the stealthier that you are and the more you try and evade detection, typically the longer the test takes, because you can't use a lot of the automation that you can in some organizations that may not have that level of visibility.
Yeah, that's absolutely right. It's one of the things that we tend to see also with a lot of these vendors who are coming out with pen test in a box style tools. They might work really well in a lab. They might work okay in, say, your 95% of the bottom of the barrel organizations who don't have a very good security policy. But when it comes to emulating actual threats and putting effort into covert operations, you're not going to get much in the way of anything of that. So that vision that an operator provides is something that you definitely still need to have as part of the equation. But on the note of Agile, let's see if I can share my screen here. Is that working?
Yep.
Okay. So what I've been working on for the past year and a half or so has been essentially a toolkit to help you build backdoors more quickly. What we tend to see as being the biggest hurdle to overcome isn't actually the technology problem, and it's also not really it's not the technology problem, and it's not the getting it to bypass antivirus problem. As soon as you do something custom, it tends to just work. But to make it work, you've got the same problem that Metasploit had back in the day, where you have to build, anyone who wants to be an exploit developer also needs to build a payload for that exploit to trigger, then give you access or to use that code execution in some kind of way. So you have all of these other things that you have to build at the same time. So at Black Hills, we built like 3 or 4 of these different command and control servers, data models to store the C2 communication that's going back and forth, session management systems to be able to handle the individual backdoors as they come back, and UIs to then control and use all of them. This is all work that could just be reused if you had a system that, say, had some kind of specific way of making these calls or making your traffic look like, so that you can simply add on to it. And so that's what this is. Emergence is a API, if you will, for pen testing tools. And so here you can see very quickly that if we want to make requests as a backdoor, we can pick our language just out of the API documentation. We're going to use Python for this one. So you go to Python requests, and you can actually see right off the bat, here's exactly how you make a request with your backdoor in order to have it interact with the entire UI system and work right off the bat. So let's take a look at what one of these looks like. So this here is the UI for the tool, and what it actually is controlling right now is a JavaScript-based backdoor. This is what I released at DerbyCon earlier this year, or well, I guess that was just 3 weeks ago now, so time flies. So this is what I released at DerbyCon, and it's kind of fun. If we run something with it, I'm just going to pop calc here because everyone knows calc is 100% malicious. You see it on your computer running.
Yeah, and this is the second technical segment where the defense is just to rename calc.exe, and then you're totally safe.
Totally.
I thought Microsoft patched the planet when they changed it to calculator from calc, but they left calc.exe. I don't know why they did that. But yeah, so this is a basic backdoor. It's kind of funny that this actually works. Microsoft was losing to Netscape, if you will, back in the day against Mosaic. So Netscape came up with a lot of cool web technologies like HTTPS and JavaScript. And so Microsoft essentially implemented JavaScript into the fabric of everything they were building at the time, which includes, well, all of Windows. So with JavaScript, you can actuate ActiveX objects and you can run things. And that's what this is actually. It's just JavaScript on the host. It comes up as this little scroll icon looking thing. If you double click on it, there's no warning, there's no alerts, it just runs, and there's your payload. This one's worked really well for us at Black Hills because we can just email somebody a JavaScript file. It's a flat text file. JavaScript coming across the network tends to look pretty legitimate. And then file extensions on Windows are also hidden. So we'll call it paystub.doc.js. But the .js part isn't seen, and users see this little scroll icon that looks kind of like a document. They'll double click on it, and there you go, you've got a session. This one's been really nice for us. Since it's custom, it hasn't had any signatures that we released at DerbyCon, so we'll see how long that lasts. But at that point, it's just text again. So it's pretty easy to change that up in an iterative fashion to keep it from triggering antivirus. But the real nice part about this isn't necessarily just that backdoor. Of course, whenever you're releasing a new tool or framework like this, you need to have some candy to go with it. So that backdoor, called Gryffindor, is the candy.
Gryffindor. Ha ha ha. I get it.
Yeah. So this whole thing got started by the military. It was their fault. I swear. They had me work on this project called Ravenclaw, and they let me just have the backdoor that I wrote as a part of it as open source. And I was going to use it at a cyber defense exercise with Will Schroeder, Harmjoy. And it was actually the exact same time I was betaing that one that he was betaing Empire right before he released it at B-Sides. And Empire absolutely wiped the floor with it. It was much, much better than mine. So way to go, Will. But ever since, I've been naming everything Harry Potter convention style. So this toolkit for all the backdoors is Diagon Alley, because why not? And then here you can see the sessions are Gryffindor sessions here. But this, of course, can work with whatever backdoor that you make that makes those same API calls. So to keep the Harry Potter thing going, why not make Slytherin here? Because it's Python, so it's got to be, right? When it comes down to it, if you take that little requests here and you paste it into, say, what the Python program is that you're making, it's pretty darn simple to start creating a backdoor here. So Python has this module called requests. And what request does is it makes web requests. For a backdoor, generally speaking, we kind of see a tilt when it comes to the covertness, if you will, of your command and control channel. That's the channel that your data rides in and out of the network on. We see like socket based, like you would see with, say, an interpreter that's coming out default on port 4444 as the most simple, the easiest to detect because it's a long-term straight up session that's connecting into the environment. So as blue teams get a little better, they can find those and kill those pretty quickly. Then you start to see beaconing malware come out. And this is an example of that. Here you've got a beacon timer here. That's set to 3 seconds. We'll get into exactly how that works and what we're doing. So you get into beaconing malware here. And then blue teams, if your beacon time is, say, very short, so it's not a direct session, which you're seeing a lot of traffic being generated, blue teams tend to be pretty decent at starting to find that as they get a little bit more mature. Then when you get into other channels, like, say, ICMP or DNS, for the vast majority of blue teams that we see, it's completely missed by them. They have no idea what's going on. However, blue teams that have been there before and been burned by it, if you know what to look for in DNS C2, it's really quite easy to see it, at least if it's based on DNS C2, especially if it's via text records. So when you start to see more mature blue teams, your DNS channel just disappears immediately because they're quite wise to it. And then you get back into beaconing malware, except now you start to do some fun things, like setting up jitter timers on there, using longer term beacon times, being a bit more patient whenever you're doing your covert operations. It's kind of funny how we see that transition from one go back to the other.
Matt,
one thing that we do consistent. Yeah.
If your C2 server is 127.0.0.1, you always will bypass any kind of beacon detection on the network. Just thought I'd throw that out there.
See, I don't like to lose. That's why I just hack myself every day.
It's always successful.
I'm not going to fight back.
Especially the social engineering and the phishing part. Oh, that email looks totally legit. I know the guy that sent it.
When I ask them to turn off the firewall, they always do it for me. It works every time. Yeah, but actually it brings up a good point. So here, the C2 server IP address is just there in plain text in the malware. What you'll generally see most tools do that are generating a payload for you is they'll take your L host or your R host variables and they'll plop them in here. But if you're building custom backdoors that you're going to use maybe in a one-off scenario because AV is getting in your way and you need to have something custom just off the shelf real quick that you can snap together to work, well, it's your code, so you can change up those variables manually. You don't actually need to have some kind of complicated generation tool to do all of the creation of this end-to-end. And I think that's one of the reasons why we don't see a huge amount of malware development just by pen testers in general in the wild, is because they're looking for this full suite. But that takes a lot of work. That takes years of development in order to produce something like that. So when you're trying to build one-off malware, absolutely, type in 127.0.0.1, gets them every time. But yeah, so essentially what we're doing here is we're combining two of the most common things that you'll see traffic-wise on a network, and that's just web requests, because web requests are just always there, and then JSON, because you see a lot of JSON traffic, especially these days when websites are starting to move to these single-page JavaScript sites. So all of their information is transmitted back and forth in JSON blobs. So if we combine these two imports with Python, we can make a backdoor really, really quickly. So we take a look at this one. This is essentially just that requests pasted in with a couple extra variables we'll talk about here in just a second. If we run that, it hits the C2 server allegedly, and then it comes back, and we can see here that what it's returning back to us is the command that whoever was typing the commands for the backdoor to run that you want to run. So now if you're going to have a full backdoor, what we want to do is have this ability to beacon like that. We want to have that happen on an interval of some sort. And then we want it to run whatever that command is. In this case, it looks like it's trying to run the dir command. We're telling the backdoor to run the dir command. Then we want to take what the response is, and we want to hand that back to the C2 server. So this is just a sequence of API calls in that case. So here's an example of that. So when we want to execute things, we've got the subprocess module in Python. Subprocess is really, really nice because it lets us run stuff, and it also lets us interact with standard input, standard output, and standard error so that we can see the response of all three types as they come back. So when we run that, essentially what we're doing is we'll take the beacon here, so a beacon pulls out, and then we will run that here, right there like that. And that's that subprocess command. We get the return value here. And so the way that it expects to have the response come back, and this is in the documentation as well, is as a base is 64 encoded blob. This is a basic HTTP listener, so it's the most simple that you can really do. It doesn't actually have any kind of encryption. Of course, when you want to do a little bit more, you probably want to have this over an HTTPS channel and then AES encrypted across that channel. But if you're just building a real quick backdoor to prove to the client, hey, I can get code execution, hey, I can buy your AV, bypass your AV or your EDR product, we don't necessarily need that. But do be aware that this is base 64 encoding, not encryption. So on a basic HTTP listener, all the traffic you push back and forth is going to be unencrypted. So OPSEC. Okay. And then so here you've got this agent ID thing. And so the way that say a more mature backdoor and the way Gryffindor works is it will automatically generate a random ID for the agent. And that's what the C2 server uses to track the agents. But again, if you're building a custom one that you're going to use each time you use it, you can set it up or change the code real quick and then run it. You can absolutely just hard code in your agent ID, which is what we do here. So then it's running. Here, what you get back, if you noticed, is this JSON blob, but you also get the HTTP headers. There's ways to not do that, but it's much easier just to split out the data. So what we're doing here is we're just splitting and taking the second half after that bracket and then adding that bracket back in so that we have our full JSON payload here. Then this if statement's just comparing the previous one to the next one so that you don't rerun the command every time that you beacon. There are, again, better ways to do this. You can track the commands. You can even, if you looked at the specification here, there's a room for a task ID so that you can track which task you ran and make sure you don't run the same task number each time. But again, that's more complex. We're worried about making a very quick and easy backdoor that's simple. Simple's nice because it's harder to detect. And simple's also nice because it's really quick to write one of these. In fact, you can spin up something like this in the middle of engagement within an hour or 2 hours, and you'll have a brand new backdoor that's not been seen before. And you can also do anything that you want now with this payload. So in the case of this one, it's a Python backdoor. You can use py-to-exe or py-installer if you wanted to make an executable that you can just drop. In the case of a Python one, it's nice because it's natively installed on most Unix systems as well as Mac OS X. So if you have JavaScript backdoors, but they don't work because you're in an OS X environment, you can absolutely do something like this right on the spot to whip that out. Okay, and then now after you get this return value, you need to format that back into the JSON response. And we can see the JSON response by going back to the documentation here and going to C2 response. That'll show you what that should actually look like. So in this case, we base 64 encode that, and then we format it into a JSON object. Now this is an interesting thing about Python. Python has dictionaries, and dictionaries are essentially named lists or named arrays, arrays indexed by name as opposed to number. And JSON is essentially the same kind of thing, but Python and JSON don't automatically work together. So that's why we use this JSON library. And essentially, we're converting between dictionaries and JSON objects here when we do this JSON loads to make the Python dictionary. And then here with the JSON dumps, we're doing the reverse of that to take that Python dictionary that we've made, turn it back into JSON so the server can accept it. And then we just send that off and sleep, go back to our infinite while loop because we never want our backdoor to stop. And essentially, that's all you need. So in this case, let's give this a different ID because I think I've already got one like that. Save that. We run this guy. Here we should see a new session pop up. Because this is a really basic one, it doesn't know what kind of backdoor it is, so it just names everything Gryffindor by default. If we interact with 3, we should be able to run calc, watch the demo fail. It really is going to fail on me.
You cursed it.
Well, you did tell you to watch it fail, right?
Shucks. Index out of range. Wait, what?
Wait, what?
I get that. I get that a lot when I code in Python. Just FYI.
Oh, there comes the calc. I'm not sure why that happened and why the second time you run it, it just automatically works. But
yeah, I think index out of range just means you need to run it again.
Yeah, pretty much. Right, so there comes the calc.
Actually, the last time I got that error, the same thing happened to me. When I ran it again, it worked. And it was some kind of timing thing with the API I was working with. I'm pretty sure it was index out of range. Go ahead, Carlos.
It could be just an index variable that just keeps getting added or being brought up. So it could be the session number that you can there.
Yep.
If you're using that as an index.
Yeah, I think you're probably right. Which just actually means it needs to be in a try except, because it'll create that afterwards, but it is in a try except this piece isn't. Yeah, so if we were to put that in a try except, after the first time it tries to beacon, it gets nothing back because there's no data for that session variable, then it would probably still work. Yep.
Yep. I love it. We're helping. You're welcome. Just debug your code live on the show. It's great.
Dev.
Carlos?
There you can see you have an index of 1. So the thing would be to check to make sure that it's actually not null, and then index it.
How do I get out of this thing?
I know who I'm sending my code to next time I get index out of range or any kind of Python error. It's calling on you, Carlos.
I'm pretty sure it's just a bug in Python.
Let's go with that. We'll go with that, Matt.
Yep. And speaking of seeing JSON all over the place, Mr. Wood, did you have any questions?
No, but I kept flinching every time I heard JSON. I was like, what? Oh, no, it's still not talking to me.
Sorry. Go ahead, Matt.
That's about all I got for the demo. Questions? Concerns for my sanity?
So we've had those questions for a long time, Matt. Don't worry.
Me too. Every time I wake up and look in the mirror while I'm shaving, I'm like, why'd you get up today? That's a good question.
Nice.
Hang on, Lee. Did you
hack the planet? That's why.
Lee, did you have a question for Matt?
Yeah, I did.
Yeah.
How big of a deal would it be to use, say, an HTTPS C2 server instead of HTTP?
Oh, not at all. In fact, this is just for the basic HTTP listener in the C2 server, which is called Oculus. If you used an HTTPS listener, then you could do that as well. You just would have to make sure that the requests you're making are HTTPS. In the case of this Python backdoor, you would add an S after the P, and I think that's all you would need to do.
Fancy.
I was thinking about it because I live in the .gov space, and there's been so much effort to get away from HTTP to HTTPS. You'd blend in really good.
Yep.
In most cases, that base 64 encoding would probably be enough obscurity to not set off in a... Well, and again, it goes back to our earlier conversation about the maturity level of the organization, right?
Yeah. So one of the things you mentioned...
As a pen tester, you want to be very careful about what you might be exposing on the network because you're the security professional, right? So
you don't want your Python or your backdoor to be exposed, Matt. Just speaking from experience there.
Could not help yourself.
Yeah, because your fish might bite your finger.
Carlos?
Yeah, can you guys hear me?
Yes.
Okay, so one of the things that you mentioned was that you're finding yourself an environment where EDR software is finding your rats, and that's the same thing we're facing at Trusted Tech, and just like you guys, we're building our own payloads and everything. One of the things that we also notice is that some of them are very good at triggering parent-child, command line parameters, and some other stuff. So right now, are you guys able to leverage Windows APIs with your payloads? So you have to depend on living off the land. I'm starting to see that living off the land is not kind of like the best way to move forward, given some of the intel that some of the EDR products are using.
Yeah, that is a really, really good point. So we're seeing a lot of that too, where it's like you're living off the land's being burned out from under you. And sometimes it's not even being burned out, it's the salted earth and it's poisoned. So you better not touch the land, because the moment you do, they know exactly what you've done, you dirty, rotten hacker, because they have their insight into command line parameters being run. So we're looking at a lot of different ways to get around it. Sometimes you just do something different. So sometimes you get away with using WMIC process call create instead of CMD. So WMIC is actually a shell in and of itself. If you're not on Windows 10 and Windows Server 2016, command.com is still there. I mean, CMD.exe was a replacement for it in Windows 95, but you still see it all over the place. So there's ways to...
But since you guys are already using Python, why not simply use the WMI library for Python and just use straight out WMI, so you guys don't have to use WMIC? Because one of the problems of using WMIC and doing Win32 process, that then you're going to have WMI PRVSC.exe being the parent process of your payload. And now we're starting to see some of the EDRs actually catch that. They're kind of building this big whitelist that says, oh, if it is netstat.exe, it's okay because Nets is and Qualys do netstat.exe. But if it is anything other than netstat.exe, for example, we're going to flag this as suspicious, and they're going to bring it over to the console that, like, WMIPRV.se initiated this process. It is not a normal process in our library. Is this okay, yes or no? So we're starting also to see that with some of the
so there's
EDR.
so many different things you can do here, and I think it really depends on the EDR solution you're fighting. Because if it's not doing a very good job, you can just use something else. But if it is, then there's other things you have to do, like just writing things in C# and .NET integration has been really powerful. If you really were desperate, we have not done this, but do you have any idea how many local binaries on Windows are vulnerable to format strings attacks? Like ping.exe is vulnerable to format strings, which means you can technically make ping run anything that you want it to.
And one of the beauties is WMI-sim, because with WMI-sim, one of the things that you can do is, I want to manipulate a service, I manipulate the service, and I have to do sc.exe. With WMI, I can create scheduled tasks on the most modern versions of Windows. We have two different classes that I can create a scheduled task. I don't have to no longer use ACH task or add.exe to create my task. Also, if I want to, let's say, manipulate processes, stop process, suspend a process, set a process in debug mode, I can do all of that stuff via WMI, which I no longer need to live up the LAN. Instead of living up the LAN, I'm living up the API, which then brings you kind of like a deeper into the OS, where a lot of the EDR products are actually, well, with the exception of one, they're not looking at that stuff.
Do you guys want to? Do you guys want to be alone? It's okay. We can raise.
We'll just watch videotape. Cameras are rolling.
It's my job. It's my job at Trusted to build all the tooling for the recommend the insert response. No, I'm having the same issues that they are having, and we're going through the same pain.
Yeah, you guys should totally get together.
We just had a orgasm here.
In all seriousness, you guys have very similar roles and working on similar stuff, so that's awesome. Glad our listeners got to be in on your conversation too. That's great. Of course, bad for you if our listeners are listening and coming up with ways to kind of mess up everything that you're talking about.
.NET is an area that I'm seeing a lot of pen testers actually moving to.
Yep.
And sadly, .NET is getting burned. For example, in the case of Endgame, they've been releasing quite a bit of good tooling to track .NET actions. And right now, before, if I wanted to bypass Sysmon and I wanted to load a DLL into memory, and that DLL was my RAT, I can just do load assembly. I can just load my assembly as a byte array in C# or PowerShell. Sysmon would be completely blinded, and some other tools would be completely blinded. But then Endgame goes like, oh, you bad boy, you're doing that, don't do that. And they're actually flagging on it. And by them open sourcing their library, I'm just thinking that .NET is going to be dead in the next couple of years. And everybody's going to have to revert back to the good old days of C++.
Oh, God.
No.
Oh, wait.
Yeah, it's
My
just
skills
like
are back.
it's like
I'm
yeah,
relevant
right.
again. Wait,
It's
I
just
forgot all
a
my
Yeah, I forgot it
total-
all.
yeah.
That was back in the 90s.
cat
I'm
and
done.
mouse game. So, Matt, thank you so much for appearing on Paul Security
I
Weekly.
have a quick one. Matt, where can we find said code to do said things?
It's all on GitHub, and it's got a website too, prismatica.io. It's actually a GitHub site, so everything actually is on GitHub. It's all open source and mostly JavaScript and JSON. So, ouch.
Nice.
Awesome. To hear more and learn more about the Black Hills folks, you can go to blackhillsinfosec.com. Even when you fill out the contact form, you can check that box that you heard about it on Security Weekly. Matt Toussain, thank you very much. With that, we'll take a short break, come back, talk about the security news. Stay tuned.